What's up, everybody, and welcome to section 1.1, Real Numbers Algebra Essentials. Let's do it. The square root of 2, an example of a rational terminating, rational repeating, or irrational number. Tell why it fits that category. So a rational number is a number that can be represented as a ratio of two integers. For example, 1/2 would be a rational number. 4/1 or 4 would be a rational number. 1/3, even though it's repeating, would be a rational number. Square root of 2 is not one of those numbers. It cannot be represented as a fraction or a ratio of two integers. Moreover, a square root of any non-perfect square, so like square root of 3, square root of 7, none of those are rational numbers. They're all irrational. And if you plug that into your calculator, you'll see that the decimal does not terminate. It goes on and on, but it doesn't have a pattern. It doesn't repeat. So again, when you think about somebody who's rational, you can kind of predict what they're going to do. Same thing with a rational number. You can kind of predict what the next number is going to be. With an irrational number, you cannot predict, therefore it is irrational. What do the associative properties allow us to do when following the order of operations? Explain your answer. So there's two types of associative properties. There's the associative property of addition and the associative property of multiplication. And both are essentially the same. So if we have 2 plus 7 plus 6, associative means we are associating by using parentheses. The associative property of addition says that if I place parentheses here, the result will be no different than if I place parentheses here. And we can test that out, right? If we have parentheses here, that means we do 2 plus 7 first. That's 9 plus 6 is 15. Conversely, if I place parentheses here and here, I would do 7 plus 6 first, which is 13 plus 2, and that would still give me 15. So we see the result is not changed. Likewise with multiplication, 2 times 7 times 5. If I place parentheses here and group these together, associate these together, I would do 7 times 5 first, which is 35, times 2, which is 70. Alternatively, if I place parentheses here and here, I would do 2 times 7 first, which is 14, times 5, which again is 70. Now we're going to carry out this problem using order of operations, aka PEMDAS. And the reason why I put M and D in blue and A and S in red is because multiplication and division are actually on the same level. When we're choosing between those two, it's just whichever one is more on the left. Same with addition and subtraction. And in the front, of course, we have parentheses, aka grouping, and then exponents. So here we're going to start with the parentheses, of course, but within the parentheses, there are operations. There's division and exponents. So exponents trumps division. So we got 3 squared, which is 9. And you see I've now rewritten the rest of the problem. So then we're going to keep going with parentheses. Now I'm going to do 81 divided by 9, which is 9. Now we've got division and subtraction. Division first, 6 divided by 2 is 3 minus 9, which gives us -6. Done. Once again, we're going to do parentheses first, but we got 2 sets of parentheses. So I'm going to go to the most inside set first. So I got 8 minus 4, which is 4. Then I've got 4 squared within those parentheses, so I'm going to do that first. 4 squared is 16. Then I got 16 divided by 16, which is 1. And then 1 squared is, of course, 1 times -2 is -2. Boom, done. Here we're going to do parentheses first, 5 minus 8, but don't forget that 3 outside of the parentheses, that's actually multiplication. We don't necessarily need an X or a dot. Just a number next to a parentheses indicates multiplication. But first we're going to do 5 minus 8, which is -3. And then we got 3 times -3, which is -9. Done. We're going to do parentheses first here, 36 divided by 9, which is 4. Next we've got division and addition. Division comes first, so 12 divided by 4 is 3. And 3 plus 6 is 9. Done. Here we got subtraction, multiplication, and addition. So we're going to do the multiplication first. 12 times 2 is 24. Now we got subtraction and addition. Like I mentioned before, subtraction actually is not before or after addition. They're the same level. So here we're going to go left to right. 3 minus 24, which is -21. And then -21 plus 19 is -2. Boom, done. Here we're going to do the parentheses first. 6 plus 4 is 10. Next, I'm going to go left to right because, again, addition and subtraction are on the same level. So 5 plus 10 is 15 minus 11. 15 minus 11 is 4. Boom, done. Here we got multiplication, division, and subtraction. So multiplication and division are the same level, but we're just going to go left to right. So first we're going to do 14 times 3, which is 42. 42 divided by 7 is 6. And, of course, 6 minus 6 is 0. Here we're going to do the multiplication first. So 2 times 2 is 4. Then I'm going to go left to right with addition and subtraction. So 6 plus 4 is 10 minus 1 is 9. Done. Here we got exponents, multiplication, and addition. So we're going to do exponents first. 2 squared is 4, and I'm going to keep it in the parentheses. Next, we got to do multiplication. 4 times 4 is 16, and as I mentioned before, those parentheses indicate multiplication. Last but not least, 9 plus 16 is 25. Done. We're going to do exponents first. 5 squared is 25, and then rewrite everything else. Then we're going to do the division next. 25 divided by 25 is 1 minus 7 is, of course, -6. Here we've got multiplication, subtraction, and multiplication. So we're going to do the multiplication first, starting from left to right. So 2 times 4 is 8 minus 9 times -1. Then I've got 9 times -1. You can also look at this as a -9 times -1. What I always say is that minus sign is sticky. It sticks to the number on the right. So I'm going to consider it a -9. -9 times -1, negative times a negative is a positive, so it's a positive 9. Last but not least, we got 8 plus 9, which is 17. Done. First, I'm going to do the parentheses. 3 minus 1 is 2, and then we'll leave it in the parentheses, because again, this indicates multiplication. Now we got multiplication and division. Since multiplication is on the left, we're going to do that first. 12 times 2 is 24, divided by 6, and 24 divided by 6 is, of course, 4. Done. Now we got a little plug and chug. We're given a value for y, and we plug it into this expression. So I'm going to replace all the instances of y with 3, like so. Now I got multiplication happening here because a number next to a variable means they are multiplying. Same here. So I'm going to do the left one first. 4 times 3 is 12. Then I'm going to do this 2, or I'll say -2 times 3, which is -6. And then we've got to go left to right because we're just down to addition and subtraction. Again, they're on the same level. So 12 plus 8 is 20 minus 6 is 14. Done. Here we've got z equals 5, so I'm going to plug that in for all of the instances of z. I've got 5 there. And now I'm going to carry out what's in the parentheses first. Now notice we have parentheses here and here, but nothing's really happening in those. Here we have addition happening. So I'll do 1 plus 4, which is 5. Then I'm going to go left to right with the multiplication. So first I have 4 times 5, which is 20. Then I've got 2 times 5, which is 10 times 5, which is 50. And now I'm going to go left to right. 20 minus 50 is -30. Minus 36 is -66. Done. Here I'm going to plug 2 in for x. And notice how when I'm plugging in a number for a variable, I'm encasing it within these parentheses. And again, that helps me to remember that I'm doing 2 times 2. Now, I'm going to do this 2 times 2 before that exponent because they're kind of within these parentheses here. So 2 times 2 is 4. 4 squared, not -4 squared, because that negative's on the outside. 4 squared is 16, and that negative just kind of stays there. Then I'm going to go left to right. -16 plus 1 is -15. And then -15 plus 3 is -12. Done. Here we're going to plug 0 in for c, so it's going to be 11 times 0. And 11 times 0 is, of course, 0. And then 0 minus 4 is, of course, -4. See how we're doing everything within the parentheses first. Then 2 times -4 is -8. And -8 minus 36, that's combining 2 negatives. So -8 and -36 is -44. I'm going to plug 1 in for w. First, we have to do the exponents. 4 squared is 16. And of course, I'm doing parentheses first, but the exponents is the first thing within the parentheses that I'm taking care of. Then I'm going to do 8 times 1, which is 8. Then we complete the subtraction within the parentheses. 8 minus 16 is -8. And then, of course, 1/4 of -8 is -2. And these questions were meant to simplify, aka combine like terms. So first, I'm going to simplify all of these operations. So 2y stays as is. 4 squared is 16, and then minus 11. These are like terms because they both have the variable y. So it's just like 2 minus 16. It's just 2y minus 16y. So what's 2 minus 16? It's -14. The y just stays there with it. Minus 11. These are not like terms, so we are done. Here we're going to simplify by multiplying the 3 against the 4, because this entire expression is multiplying that 3. So I've got 3 times -4, which is -12. And again, we have like terms. We have 2 terms that have b in them. So it's just like 8 minus 12, but it's 8b minus 12b. 8 minus 12 is -4, and then we keep that b with it, plus 1. These are not like terms, so we can't do any more. So we're done. Here we're going to square that 6 first and make that a 36. Then the 36 multiplies the z and it just puts it at the front. Same exact thing, we'll just look at it as 36z. Now we got like terms here and here. Now some people might see this subtraction and be like 7z minus 36z, but that minus sticks to the number to the right. That's really a negative 3. The 7z is positive, so is the 36z, so they just add. So we get 43z, right? 7 plus 36 is 43, minus 3. These are not like terms. We are done, and that's it. Here we are going to start by distributing the 9, because we got y plus 8, but they're not like terms, so they can't combine. So we're kind of frozen in terms of what we can do within those parentheses. So I'm going to distribute. 9 times y is 9y. 9 times 8 is 72. Now we're going to combine like terms. We got 72 minus 27 because they're both constants. 72 minus 27 is, of course, 45. With the 9y up here, these are not like terms, so we're done. So first things first, I'm going to carry out this multiplication because I can take that negative 3 and multiply it against the 6 coefficient of the b. So negative 3 times 6 is negative 18. Again, you might be saying, why are you calling it negative? It's minus. It's essentially the same thing. We can either call this plus negative 18b or minus 18b. Now I got two like terms, 12b and negative 18b. So 12b minus 18b is negative 6b. And then we still have the 6 out here. Since these are not like terms, 6 minus 6b is the answer. Done. First, I'm going to square this fraction. So when you square a fraction, you just square the numerator and the denominator. 4 squared is 16. 9 squared is 81. And then we're multiplying against 27x. And I'm going to place that 27x over 1. I'm also going to change this multiplication sign to a dot because I don't like having an x multiplier when I'm using x as a variable. Now, I can just multiply across if I want, but that's going to be a lot of big numbers. Instead, I'm going to cross simplify across the numerator and denominator of these fractions because both 27 and 81 can be divided by 27. 27 divided by 27 is 1. 81 divided by 27 is 3. Then I'm going to multiply across, and we're left with 16x over 3. Done. First, we're going to take care of what's in the parentheses, and we can add these, and we can also add these. So first I'm going to do 2 plus 3, which is 5. Then I'm going to do 2x plus 3x, which is 5x. Then I'm going to multiply. I'm going to carry out the multiplication. The 5 can multiply the 4. And in the same way, this 4 or negative 4 can multiply that 5. And of course, that 4 times 5 is 20. So now we've got addition and subtraction. Once again, addition's not before subtraction, but because it's on the left, we got to do addition first. So 9x plus 20x is 29x minus 20x gives us 9x. For the following exercises, consider this scenario. Fred earns $40 mowing lawns. He spends $10 on MP3s, puts half of what is left in a savings account, and gets another 5 for washing his neighbor's car. And notice I'm always underlining numbers even when they're in word form like half. So it says, write the expression that represents the number of dollars Fred keeps and does not put in his savings account. So I'm going to piece this together just like I'm piecing it together in my mind. So check this out. First, Fred gets 40 bucks. Great. Then he spends $10 on MP3. So that's like losing 10 bucks. So I'm going to subtract 10. Then half of this amount here goes into a savings account. Well, we don't want the amount in the savings account. We want the amount outside of the savings account. So if I put half of this in a savings account, that means the other half is not in a savings account. So right here, we have an expression for that amount that's not in the savings account. Plus, he gets another $5 at the end for washing his neighbor's car. So now I've got an amazing expression that represents the amount of money that he has that is not in his savings account. Just for fun, it doesn't ask for this, but just for fun, if you want to know what that answer is, following order of operations, we do 40 minus 10, which is 30. And then 1/2 of 30 is, of course, 15. And then 15 plus 5 is 20. So he's got 20 bucks. According to the US Mint, the diameter of a quarter is 0.955 inches. The circumference of the quarter would be the diameter multiplied by pi. Is the circumference of a quarter a whole number, a rational number, or an irrational number? So let's write out that circumference. They said it's 0.955, which is the diameter times pi. Now, first and foremost, we know that 0.955 is a rational number because it's a terminating decimal. But what about pi? Pi is a very classic example of an irrational number, meaning it does not terminate. The pattern is not known in terms of the decimals, and it cannot be represented as a fraction of two integers. So the real question is a rational number times an irrational a rational or an irrational? Well, let me tell you this, it's going to be irrational. It's still going to have a repeating decimal because pi already repeats, and the pattern is still not known. You're just taking a pattern that we don't know and you're multiplying it by 0.955. So it's going to be a new pattern, but it's still going to be one that we can't predict. So the answer is irrational. Done. For the following exercises, consider this scenario. There is a mound of G pounds of gravel in a quarry. Throughout the day, 400 pounds of gravel is added to the mound. 2 orders of 600 pounds are sold and the gravel is removed from the mound. At the end of the day, the mound has 1,200 pounds of gravel. Write the equation that describes the situation. So I'm going to create this equation. Again, an equation has an equal sign, whereas an expression does not. I'm going to create this equation as we walk through the scenario. So first, I start with G pounds. Then throughout the day, 400 is added. So I'm literally going to add 400. Then it says 2 orders are sold. That means I'm losing 2 orders, and each of those orders has a value of 600. So I'm losing 2 orders of 600. And then this is basically how much I have now. And it says at the end of the day, the mound has, is. Those verbs indicate equal or equality. Has or is 1,200. And there is my equation. Now, just for fun, we don't have to do this. It doesn't ask for us to do this, but I'm going to solve it anyways. Let's solve for G. So we're going to carry out order of operations. 2 times 600, that's 1,200. Again, that minus stays there. We could also call that negative 1,200. And then we've got 400 minus 1,200 is negative 800. Then to get rid of the 800, I'm going to add 800 to both sides. And then I've got G equals 2,000 pounds. Ramon runs the marketing department at his company. His department gets a budget every year, and every year he must spend the entire budget without going over. If he spends less than the budget, then his department gets a smaller budget the following year. At the beginning of this year, Ramon got $2.5 million for the annual marketing budget. He must spend the budget such that 2.5 million minus x equals 0. What property of addition tells us what the value of x must be? So let's rewrite this equation down here, and we'll go through the process of how we would actually solve this. To figure out the value of x, I would add x to both sides. So what am I doing? I'm adding the additive inverse of negative x. The reason why is because these cancel out. Those will go to 0. And the other side, x plus 0, is just x. So now I have x equals 2,500,000, and that's my answer. And again, the way that we got that was by the inverse property of addition. So for 61, it's asking us to use a graphing calculator, but I'm going to go ahead and do it without one. So first I'm going to do the parentheses. 0.25 minus 0.75 is negative 0.5. Negative 0.5 squared is like 5 squared, which is 25, but there's a decimal there, so it becomes 0.25. And it becomes positive because a negative times a negative is a positive. Then I'm going to add 7.2 to both sides. That's going to get rid of it. On this side, we're combining a positive with its opposite, so that's out. Then I've got 9.9 plus 7.2 is 17.1. Last but not least, I'm going to divide both sides by 0.25. And by the way, when you divide by 0.25, it's like dividing by 1/4, which is the same as multiplying by 4. So 4 times 17.1 is actually 68.4. Done. This says determine whether the statement is true or false. The multiplicative inverse of a rational number is also rational. First of all, a rational number is any number that must be able to be expressed as the ratio or fraction of 2 integers. So for example, negative 1/2, positive 2/3, negative 7/9. These are all rational numbers. So the multiplicative inverse of a number is the number that when you multiply it against that multiplicative inverse, it's going to get 1. So for example, negative 1/2 times what is 1? It would be negative 2/1. This one would be 3/2. And this one would be negative 9/7. So you see, if we're starting with a rational number, by definition, the multiplicative inverse is going to be the reciprocal of that. It's still going to be a fraction. It's still going to be a ratio of 2 integers, which means that this is true. Here we are asked to determine whether the simplified expression is rational or irrational, and that will come down to whether or not this inside the square root simplifies to a perfect square. If it does, it's rational. If it doesn't, it will be irrational. So carrying out order of operations, we do 4 times 5 first, which is 20. Then we do that 20 times -1, but it's really a -20 because of that minus sign. So -20 times -1 is +20. And then I'm going to do -18 plus 20, which is 2. So since 2 is not a perfect square, the square root of 2, therefore, is irrational. Done. The division of two natural numbers will always result in what type of number? So what are natural numbers? Natural numbers are 1, 2, 3, 4, 5. They're like whole numbers that you just don't include 0. So an example of a natural number would be 1 divided by 2. But we got to remember that division can also be represented like this, like a fraction, because this bar is really just a division bar. So two natural numbers dividing would be like 1 divided by 2. We could also have 7 divided by 15, which could also be written as 7/15. But the point of this question is recognizing that division is really setting up a fraction. And what did we say earlier is that as long as it's a fraction of two integers, and in this case is a fraction of two natural numbers, which is a subset of integers, the resulting number has to be rational, which means the division of two natural numbers will always result in a rational number. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.